Welcome everyone. Today we're going to be talking about some lessons learned in designing backup power systems. This is based off of a wind event for the last week in Colorado, where this was the first real test of about a dozen new customers using the Midnight all-in-one inverter systems. And also just general background from a number of other systems and how well they operated during this event. The power was down both from trees on the lines and planned outages from the fire danger for up to 5 days in some cases. Some people had power on and off during that time. Some people it was out for the entire time. So fairly extended situation with need for backup power. And we're going to talk about essentially all of the things that didn't work as smoothly as desired and what we can learn from that. First, going through some of the design issues and also programming issues for the systems. We'll talk in more depth about the batteries and the PV arrays. But one issue that we saw a couple times was just too high of load, and this was usually from putting the entire house on backup power, an entire 200 amp service panel on a single inverter, which is only 42 amps of continuous output power. Sometimes this was due to the design, sometimes it was due to loads being changed. One case it was a house that had fairly minimal loads, so it was deemed reasonable to back up the entire 200 amp panel. And then during a remodel, they decided since they now had solar, they should throw in a whole bunch more electric appliances and some electric stoves, electric water heaters. A lot of fairly high energy or high power loads were put on the 200 amp load panel, and now that single 10 kilowatt 42 amp inverter was not sufficient, and it kept shutting off because of overloads. Another thing we saw a lot was just too high of loads as far as energy use and draining the batteries too quickly for a long outage. Short outages of an hour or two previously hadn't really shown that to be a problem, but when you start getting 50, 60, 70 hours of outage, then all of a sudden these kind of longer time loads, even small electric heaters, were really draining the batteries more than they could stand. So essentially all of these were related to electric heating loads on the backup power. Had a few cases where we had incorrect behavior of smart loads, where they were supposed to dump some of these heavier loads if the grid went down and they were on backup power for too long, and just incorrect programming of them didn't happen. Some cases we had calculated for loads, but the loads were much different than estimated. One case was a hot tub where we calculated it based on about a 15% duty cycle, but with 80 mile an hour winds and the hot tub on a very wind exposed deck, that hot tub was running about a 40% duty cycle and using about 2.5 times the energy use as we had anticipated, so it started draining the batteries a lot faster than we thought. So a lot of circumstances where we just had the incorrect stuff on backup power, where there was a separate backed up power panel, but the right circuits didn't get transferred over. Some heating circuit, some random pump that we didn't know about ended up on backup power. Also a lot of circumstances where there was a circuit that should have been on backup power that didn't end up on the backed up power panel and caused issues there. A lot of issues with internet, where they got the main router on backup power, but often a repeater that was needed to keep Wi-Fi to the inverter was not on backup power. So then the inverter went offline, which messes up a lot of the monitoring, the ability of the installer to see the monitoring remotely. And a lot of the customers didn't really realize the difference between logging in remotely versus connecting directly to the inverter via Bluetooth. So when they lost Wi-Fi to the inverter, even though it was backing up a bunch of stuff, when it lost the online connection, there was issues. And just lots of issues with not knowing what was on backup power and being confused on that. Whenever you're retrofitting an existing house, figuring out what circuits do what can take quite a bit of time. And often it's just pick a couple easy ones, and then you don't find out till later what's really on backup power. Sometimes we had where we're using the smart load outputs that the wrong loads were on those, and it didn't behave as expected. Like I said, losing the internet connection for the inverter was a common one, where it wasn't really taking into account some Wi-Fi repeater needed for the inverter, even though the main internet was backed up. And in a lot of cases, we found that the priority of both smart loads and backed up loads in general changed once they are a couple days into the outage. When their customer is initially thinking about what do they want backup power for, they usually come up with a list. But if you actually turn off the grid power for a few days, they're going to find other things that they didn't initially think of. They're like, oh, this really needs to be on backup power. One, it's like, oh, the garage door openers didn't end up on backup power. So I got everything else working, but I can't get the garage doors open. One of them, the EV charger, wasn't on backup power, and it was a nice sunny day, and their batteries had fully charged up, and they wanted to charge the EV. But because they hadn't set it up to be able to do that at all, they couldn't do it. Now, EV charging is definitely one that we generally don't want to have pulling off of our backup batteries unless we have a really massive backup battery system, just because the size of typical EV batteries is often larger than the typical backup batteries we're using for houses. But if we have extra sun, we can use the smart load outputs to be able to do EV charging even when the grid's down. We had some where they just forgot about extra freezers in the garage, and while the fridge in the house was backed up, the freezer in the garage wasn't backed up. A lot of things where just learning a lot more about what loads they really wanted on there. One thing I recommend is people that have a backup power system is at least once a year, probably don't have to do it once a month, but at least once a year, shut off the grid for an entire day and just see what happens. Does it operate like you think it should? Does it do anything strange? Do you find that you just don't have backup power for things that you thought you did? Do you find that the batteries could go dead a lot faster than you hoped they would? Maybe because you have loads on there that you didn't even intend to back up that are just drawing lots of power. And this will also help find changes in the system over time. Especially with lead acid batteries, this was a big thing to test each year. Are those batteries still good enough to provide power? With any generator thing, it's good to test, will it still start? Does it still run properly after sitting for a year? So doing a yearly test is a very good thing to just make sure that your power system still operates as desired. And maybe you've added some new things that have changed this operation since the last time you tested it. Knowing that and seeing that in a non-emergency situation can be a lot better than during a giant windstorm when all the roads are closed and you can't even get a hold of your installer. That's something I recommend. One battery issue, most of these battery issues were on older systems, not using the all-in-one inverter. And a lot of them are a lot better when you've got a matched inverter and battery that can talk to each other. One issue we did have on some of the midnight systems with the all-in-one inverters is that the system was set up to do time of use operation, essentially operating the house loads from the batteries during certain peak load or peak rate times in the evenings. So the batteries may have been discharged quite a bit doing the time of use operation and weren't ready to do backup power. Now this is something that the end user has access to change. They can change the reserve amount of power to be kept for off-grid use and the charge from grid setting and forced charge. So what I usually recommend is make sure that the end user in this situation knows that they can go in there if there is a scheduled power outage or an expectation that there's going to be power outages, which most of these times there's at least a day's notice that there's likely to be power outages from storms. They can go in there and change that reserve capacity, bring it up to 95% instead of maybe they're bringing it down to 40% during normal operation, and hit the charge from grid and hit forced charge to top those batteries off before the power goes out. Most of the rest of these issues were ones that we encountered with older systems, usually ones where there is no communication with the batteries, so there's usually a separate state of charge indicator which can get out of balance. In one case, the batteries shut off and the state of charge meter reset to 100% when it came back on, even though they'd been around 25% before it shut off. That's a common behavior on a lot of the older independent battery meters. Some of them you can set now to not do that and to remain with their previous state of charge if they lose power and come back on. When you're doing a closed loop system where the BMS is reporting battery state of charge, this is much less of an issue. You can have a little bit of state of charge drift if you haven't gotten the batteries up to 100% regularly, but usually it's much less of an issue than on the older systems. Batteries being out of balance is also an issue on the older systems without communication and active balancing between the batteries. One issue that one system ran into is dark start issues where the batteries shut off and won't turn on long enough for any other equipment to turn on to start charging it. The midnight system with our inverter and batteries, if you have a dark start where the batteries have shut off completely from being drained too low, they will dark start from either grid power or PV power, but they will not dark start from generator power. So that's an important thing to realize. If you've got a grid down situation and you've run your batteries down too low, PV is really the only way you can dark start it to get it turned back on. You can't do it with the generator. There are some ways around that, which we've discussed in some previous webinars on generators, but in general, you need either grid or PV to dark start. Some of the older systems, we actually ran into that it would not dark start from PV, generator, grid, any source. It had to actually have an independent battery starter or a battery charger that could charge a 0-volt battery, which there are independent lithium battery chargers that can do that. But a lot of the older, like Outback and Schneider equipment, it cannot dark start a battery at all. And that can be an issue. Now, if you've got your programming correct, you should never be trying to dark start a battery that has shut off. You always want to program it so the inverter shuts off before the battery shuts off. And then if you get any of your sources back, including your generator, while the inverter brain is still on and the batteries are still on, even though it's shut off AC output, it can accept that generator input and recharge those batteries, so you're not doing a full dark start. But if you've set your point where the inverter shuts off too close to 0% on the batteries, it's a potential that the batteries will shut down before the inverter drops the AC loads, and then you've got a full dark start situation. I always recommend never running the inverter down to less than 10% where it shuts off, just to make sure you don't get too close to that last little bit and have the batteries shut off. We had quite a few issues with PV arrays. A lot of these backup power systems are just doing grid tie net metering, and they have PV arrays which are not specifically designed for off-grid use. They're low tilt angles, flush mounted on the roof, and they don't shed snow well. This is fine if you've got short outages where you're really operating from batteries for a while and then you recharge the batteries from the grid. Fine. If it happens during a snowstorm, not a big deal. But when you've got a longer outage like this, where we're looking at several days, then you really get into needing to design the system more like an off-grid system and thinking, how does my PV array relate to my loads and how much production am I going to be able to get? So this was an issue with some of these arrays, that grid was down for several days and their PV array, being covered in snow, just wouldn't recharge the system, even though that was really the only source they had. I had some issues with the version 7 firmware on our inverter. If you don't do a reset of the inverter, a full shutdown of all power sources and restart when you install the firmware, it has some issues remembering old stuff and getting confused. So this is something to remember when you're doing a firmware update, is make sure that once you've updated the firmware on the inverter, you shut all power sources down. That means shutting the DC breaker from the batteries down, the PV input, all the AC sources, and leave that inverter off for a few minutes to make sure its memory is completely fresh, then fire it back up so it's operating on the new firmware without any old junk in its memory. Another issue that a couple people had is the grid. If it was going on and off, you kind of want to grab as much power from the grid as you can when it comes back on to top those batteries back off, especially if you've got snow on your PVs. That's the only chance you're going to get ready for the next outage. And depending on the settings, a lot of these systems are set to not charge the battery from the grid, because in normal operation, you don't want to do that. The grid actually doesn't, utilities mostly don't like you charging batteries from the grid. Oddly, they love you charging EVs and other batteries from the grid, but they don't want you charging PV system batteries from the grid. So the default programming for a lot of these systems is to not charge the batteries from the grid. But that is something where you'll want to go in during these situations and turn on grid charging so it can charge up during the brief returns of power of the grid, as there might be on for a couple hours and then back off again. And that happened quite a bit in some of these situations where it was charging up, another outage, charge up a little, another outage. Ran into a lot of generator issues. A lot of people kind of had, oh, here's the plug where you can plug in a generator if you need it, but it had never been tested before. It was never tested with their particular generator. And there was issues with the generator, either the voltage being out of spec, the frequency being out of spec, and therefore the inverter wouldn't connect to it and use that power. Especially with the all-in-one inverters, it's a little more picky with the generators than some of the older inverters were. And you really need to test it with the generator ahead of time as part of the installation and commissioning process to make sure with the particular generator that this customer is going to use that it will work with the inverter and have that as another backup source if you're relying on that as a secondary source if the PVs are covered in snow, for example. Sometimes this is hard because when you're doing the installation, it's just, oh, let's put in a twist lock plug receptacle so I can add a generator if I get around to it. And you don't know what generator they're going to be using. And a year later, when they do buy a generator, maybe they don't even tell you that, oh, I got a generator, and you need to make sure it works with the inverter programming and has correct voltage and all. We also had a lot of cases where the generator just didn't start for whatever reason. I've seen ones where the propane ran out, the propane was turned off, the battery for the generator went dead, various issues. One interesting one we ran into this time was the generator battery was not on backup power. So most pad-mounted generators have a charging circuit that keeps that battery charged. That circuit was not on backup power. The battery was really weak, and the system went 2 days on just battery power before it needed to start the generator. In that 2 days, that battery went dead because its charger had been hooked up to the grid power and wasn't being charged for 2 days, and it didn't have enough battery to start the generator now. So thinking about how to keep your generator happy, so a couple days into an outage, when you want to use it to charge up your main solar batteries, is its starter battery good? Has its starter battery been on backup power since the beginning? So just a lot of issues around generators. This is also something to test during that annual or biannual test of how is the backup power system doing, is do a test where you drain the batteries down far enough that the secondary backup, the generator, is supposed to kick in and charge them up. And make sure that it does that correctly. That can also be the test of the generator. This was a big one. A lot of issues with expectations and training of the end user, the customer. Starting with not even knowing when the power went out. We had one where the power went out and they didn't realize it, and the plan was they were going to turn off a bunch of the higher power loads when the power went out. Well, the power didn't go off because the system was operating correctly, so they didn't realize for an hour or two that they had sucked down a third of their batteries already because there was a lot of higher power loads on there that they intended to manually shut off. There is not a simple way to get a text or an email from the Midnight Inverter saying the grid went out. That's definitely something we're looking at adding because it's something that is a serious issue, especially if you're doing larger systems that back up the entire house. Everything's still operating. How do you even know that the grid went down until you see issues way farther on, and maybe you should have been conserving power a lot more. A lot of people didn't know how to look at the inverter screen and what it was telling them. Many customers were used to going into the app through their login, and if the internet wasn't functioning, either locally or because of larger system-wide internet outages, they didn't know that they could connect with the Bluetooth app to view it locally. A lot of misunderstanding loads and not knowing which ones are heavy loads and which ones are easy loads. This is a big issue with space heaters. People think that space heaters use power based on physically how big the space heater is. And if it's a small space heater that's not even as big as their computer, they can't see how that space heater can suck the batteries down, while their computer and the TV, which look like much bigger things in their house, are fine to operate on backup power. So some more education there on what kinds of loads are just fine to be plugging in during an outage and which ones should really be avoided because they draw the batteries down too fast. A lot of misunderstandings on which loads were on backup power. This goes back to the whole design and programming side where I talked about which loads do we want on backup power? Did the correct ones get on there? There was a lot of issues around that aspect of it. Just simply being able to see how full are the batteries. It's on the screen on the inverter, but a lot of people didn't realize that, and they're trying to figure out what's going on. Why did it just shut off in day 2? I didn't even have a concept that the batteries were getting really low. Also combined with that is when it does shut off, understanding that what battery state of charge it'll shut off and what state of charge it needs to charge back up to before it'll turn back on. This might be as simple as maybe a little note card stuck to the wall next to the inverter just saying what some of these settings are for the installers to leave there so the end user can see, oh, when it hits 10%, everything's going to shut off. If it charges back up to 25%, it'll turn back on by itself. So they're not like worrying, is something going wrong or is it behaving like it should be? A lot of educational issues with the installer really telling the end user what it should do during a case like this. And again, this is where doing this annual test of it can bring up some of these issues in a non-emergency situation and let the installer and the end user really work through what are realistic expectations and how should it behave and how do I tell what's going on and what it's doing. So that's kind of the lessons learned with this most recent one of what to do and what not to do on backup power. I'm also posting another video today on a lot of the design issues on backup power and different configurations and better and less good configurations to look at when you're designing a backup power system. So please take a look at that video as well to get into some of those design considerations and how to avoid some of these issues when doing backup power systems. Thanks for watching.